Everyone, we will just wait for a minute or so. So, like people are still joining us. So, yeah, just wait for a minute or two. We will be just shortly starting.
Harsh, are we all audible?
Yes, sir. Yes, sir. We are just starting.
Just
Hello,
waiting.
everyone. Yeah, thank you for joining us for today's webinar. So, yeah, I welcome you all to this webinar. My name is Akash Pan, and I am the digital marketing team lead at Geoinformatics. Most of the companies and people are new to this webinar today. So, we will be a little bit telling you about what Geoinformatics do in field of engineering services and sales. So, for a quick overview, Geoinformatics is the leading provider of engineering services and major measurement machines like SPM. Like today's webinar is all about a special purpose machine. So yeah, one of the domain is SPM. Another thing is that like vision measurement machine, blue light scanners, portable arm, quality management software, and many more measurement solutions. So today we are presenting customized solution for manufacturing domain with our special purpose machine webinar. So mostly the industries today which are participating with us are from EMS, automotive, aerospace, medical, solar, OEM. Okay. So the today webinar is divided into two subparts, which include 45 minutes presentation and couple of applications video and live demo of our own customized SPM. And second part, we are going to take 10-minute Q&A session where we will try to answer all your questions. So now I would like to hand over the mic to Mr. Pawan Raikwar. He is our technical head in Geoinformatics. So yeah, yes, Pawan sir, you can continue with the presentation and with this webinar.
Good evening to all. I hope I'm audible to all the audience in this webinar. I'll start as Akash was giving you the small introduction about Geoinformatics. So I'll tell you a bit about Geoinformatics, and then we'll specifically talk about today's topic, which is of special purpose machine. So I'll share my screen, and then we'll begin with the presentation part. So give me a second. I'm sharing my screen. And I hope now my screen is visible to all of you.
Yes, sir,
Okay,
it is visible.
okay, great. Okay, so as Akash told you, Geoinformatics is now a 20-year-old company, and we are into domain of sales and services both. So we have various partners along the globe. So we supplied metrology machines like VJ measurement machines, portable CMM scanners, gap and pressure measurement system, seal gap measurement systems, laser profile meters for very tight tolerances part. And we also have a domain, we also have a department called SMART. So in this department, we are serving inline and online applications, which are related to dimensional measurement and also for visual defects like presence, absence, then scratch kind of thing. So that's what Geoinformatics does. Today, as my colleague said, we will be specifically focusing on SPM. So we further focusing in the domain of SPIM, where we make special purpose machine for inspection purposes. Now that inspection can be dimensional or that inspection can be visual as well, where we assuring the part presence, absence of. So we build a custom solutions as per the industry requirement. Industry can be automobile, industry can be medical, it can be electronic manufacture. So depending on your requirement, we understand, we study what exactly you are looking for. You are looking for some visual inspection, where you're looking to get some part absence presence, or you're looking to dimensionally verify the part, and based on that you want to segregate the part. So we build a special purpose machine for this inspection, which can do this job. So brief introduction here on this my slide. If you can see what is automation, industry 4.0. So we all very much industry 4.0 is very much familiar term with the industry now, where we integrate the different technologies and centralize the database, so the process can be monitored in a better way, and we can control the things from a single source. So we do develop such systems which can interact with your server. So you can have a common database, you can monitor the process, and you can automate your process. The inspection needs are designed in such a way that it match your production speed and all that. Why automation? Like, it's not just now a requirement here, it's become a necessity, because all of us now these days manufacturing large quantity of parts, and as per the new requirement for the end customer, people demand for 100% quality assurance. We don't want any faulty part to go further, whether it can be a dimensional fault or it can be a visual fault. We want to assure we supplying a good part to a supplier to the end customers. So such systems are really helpful to assure this quality in automated way, and be able to match up the production speed. Suppose you are producing 10,000 components in a day. Now, those 10,000 components in a day cannot be checked in 8-hour shift by using a standard metrology machines like CMMs, VMMs, portable CMs, or even by the first principle. So such SPIM, we call it as SPIM. So I additionally we added for inspection. Such SPIMs will be useful to measure those parts and meet your production speed, so you can do 100% part inspections. So it is directly related to the time and cost, uh, because you are not just doing inspection based of samples, you are completely assuring the same production speed. You are doing the quality inspection, and because of that 100% inspection, you able to assure you're not making any faulty parts. So not waiting for the feedback coming from the quality department to your production flow, the part is faulty. By the time production is already produced many faulty parts. So such machines will be held on the line itself, and as soon as your production make first second faulty part, this spin will be telling you the first part is faulty, and that way it will be very helpful for you to reduce your overall rejection rate, because now it says the first or second part came faulty, you know the part is faulty, and accordingly you can do the required action on the production line. That was all about speed of the inspection. So we use various brands cameras and sensors or laser sensors. So here we can talking about as fast as 10,000 hertz. So we can capture 10,000 profiles in a second. So we can go speed as far as 2 meter per second kind of speed we can achieve of a moving object on a running line. So we able to meet the running production line challenges. As I was telling you, this surely going to contribute huge in reducing the rejection rate, because as soon as my production department produces the first part, I will be knowing. So I'm not producing much of the rejected part. I can give the immediate feedback to my production and do the required corrections. So this is how the process work by. We in general, like we take a sample on the production lot and then carry it to the standard room. Then you wait for the inspection, and by that time, your quality department inspect the part by using a standard metrology system and tells you the part is faulty. You already produce many bad parts or bad samples. But in terms of inline system, you as soon as the first part comes, you able to give the same feedback. Some pros of such systems, they are like metrology systems are highly accurate, but they are slow. They they cannot they will be depending on your human efforts, because all these traditional lab machines require operators to run. So you require some manpower to operate these machines, to print the report, analyze the report. But when we talk about inline systems, they are automated. Once you program them, they can keep repeating the process and continuously monitoring your part. So we, as I told you, we use various brand sensors and cameras. So one of them is LMI Technology. This company is from Canada. So we use such sensors to create an automated solution. That solution can be for dimensional or for the visual. Like in this slide, we are using a 3D sensor to verify electronic industry parts, where we're verifying all the features are present. And because of these high quality accurate data, we are verifying the dimensions, like the position of a hole, the diameter of the hole. So in electronic industry, on a running line, we able to measure these bodies and assemblies and show that we have no fitment failures. If any part is faulty, right away we get it segregated itself. Like this sensor can directly generate a digital output which goes to the PLC, and a pneumatic separator can remove the part from the line, or the feedback can go to the robo which can remove the part from the line. So automatically, end of the day, suppose I am producing 10,000 of such cell phone cases, and out of those 10,000, suppose 10 of the part are faulty, automatically my line going to segregate those part. So I'm sending all goods part to my customer. Second good advantage, along with the 2D camera, we're using 3D sensor. So the 3D allow us to look into the Z part of the component, and it's allow us to measure the component with a high accuracy. Here we're talking about 50 microns accuracy on a running line. So all these depth, height, width, diameters we can inspect. We can use various configuration as per the part requirement. It can be single sensor, it can be multiple sensor together. Uh, we still talking about electronic industry, so it can be a cell phone battery, it can be a PCB, it can be a cell phone housing, it can be a camera assembly. So all these small components can be verified. So the laser sensors here we're using are having high X and Z resolution, so it's help us to assure we're getting good quality of data. Then at the same time, we not just the 3D laser sensor, we also use 2D vision cameras. So because the camera has a larger field of view, and it allows us to see the larger picture at the time. So on the visual basis, like some components presence, absence, feature presence, absence, or sometimes we need to do the OCR or read some surface thing, scratch event. We use vision cameras to do these applications. And SPM, we built the combined both. Like here, we showing how a 2D vision camera verifies the one part having the feature, another part not having the feature. So this way, we assure that no subcomponent is missed from the main assembly on a running line. Like here again, you can see there's a bad part which is broken and one is good part. So we don't want this bad part to get packed and go to the end customer. So as soon as this camera find the bad part is bad, it gives the feedback to the rejection system. The part number, let's say part number 47 is not good enough on the line. It need to be eliminated before packaging. So we eliminate that part, and for the finally we get all good parts. So this is how the cameras work. And one more example, here we're checking a ball bearing. So we know in the bad one, you can see the balls are missing inside the bearing. We don't want that to go to the end customer. And the good one with all the balls are there in the bearing is okay for me. So we're not just verifying the part dimensionally by using the laser sensor, but visually of the presence of the subcomponents or defect on the component as well. Moving to the next part, again, you can see a gear over here, and one of the teeth of the gear is broken. So we are able to identify that on a running line. And on my right hand side, you can see a circuit, and you can see again a circuit chip is broken over here. on the correct on the connector. So now if altogether if I talk about SPIM, so we just not SPM, we included inspection in the part. So the technologies which I was discussing with you, like laser sensor, like 2D vision camera, a PLC, rejection system, or even a robot. So when I combine all these things, we call this as SPIM, special purpose inspection machine. So the speed, the accuracy requirements has been built as per the customer requirement. So we understand from you what you are making, what is the current challenge in that part. Suppose you're making a component where you want to verify a couple of dimensions and a couple of visual things. And we know what we ask, what is the production rate. So based on that, we create a design, what kind of sensors are required to do the dimensional measurement, what kind of cameras are required to do to verify the visual stuff, and how the entire cycle will work. So there we combine, let's say in this thing, we want to do it on a running line. So we make a design which having a conveyor belt. The part will be running on this conveyor belt. It will be scanned by a laser sensor, or image will be captured by a 2D vision camera. And then that digital output going to the separator, which will reject the bad part or good part. Same time, we also saving the data like image or the value measurement values. So we'll be knowing end of the day how many components we have measured, how many of them are good, how many of them are bad. So that's what SPM does. What was our aim? Our aim is pretty straight and simple. We want to increase the production rate because we can measure the same number of parts in which is meeting your production time. We want to optimize your quality, minimize your waste, minimize your production costs, reduce defect. Because these are automated systems, so no human intervention between. Maximize the output, reduce the manpower. Because suppose right now for visual defects we use, let's say in a single line 4 to 6 people sitting on a line just assuring all the components are present on a part or not. So instead of that 6 different operators, there may be a single person who's running this SPM, and it can inspect, let's say, 10,000 components in a day or 5,000 components in a day. Then in SPM, we have some substations like it is an input system where we talking about the loading the part. So that can be done by a ball feeder, or we can integrate a robo which can place the part. Then there's a translation system, which can be a conveyor belt, which can be a fixed station or fixed rise conveyor, which can hold a part in a particular orientation. Then the inspection system, which having 3D, 2D sensors along with the vision cameras to do the dimensional and the visual data capturing. Then the control system, which consists of PLC, HMI, drivers, and other control system to take the input from the sensor and the camera and do the next operation. And finally, a rejection system, a push or a flipper or robo, which will eliminate the good part to separate bin and the bad part to a separate bin. And then we can use a SCADA or PC to receive the data and do some analysis of the process capability. So we are making SPM for all industries: automobile, consumer product, electronics, food, beverages, logistics, medical, packaging, solar. Depending on your requirement, we build a design. Like here are a few SPMs which we already supplied to our end customers. So on the top, you can see the concept design we had made in start of the project. And at the bottom, you can see some real images of the product which we have developed as per the customer requirement. So we also having one of the demo SPM in office, which we will be demonstrating right after this presentation, just to show you how it look like, how things work. Like in the second picture, we have designed SPM which inspect the ceramic trays. One of a medical industry in Bangalore want SPM which inspect the ceramic trays, and these ceramic trays has been used to keep the medical surgical components. So they have a lines and width in the group. So they want to monitor the ceramic tray width, length, and the depth of all the groups, and automatically data will be saved and a rejection system will be implemented accordingly. So we're using a laser sensor over here. As soon as the ceramic tray pass below the laser sensor, it get inspected, and we're getting the data outputs. So we have pre-fitted the nominal and the tolerances of those dimensions. Accordingly, it get inspected and we able to judge the part is okay, not okay. But as in this case, we only require the dimensional stuff. So we have designed the SPM, which is doing a dimensional inspection only. Coming to the third one, where we have designed SPM, at the bottom picture you can see, which is doing both a dimensional and as well as the visual check. So this SPM we have developed for a brake pad industry, where we are checking a brake pad, first visually verifying the dimensions that there on the sorry the logo is there or not, the particular characters there or not, and then the dimensional verification like length, width, flatness of the brake pad, and accordingly part good part and bad part is segregated. What I will do, I'll stop my PPT here just for a moment and play a video, so it will be easier to you to understand how this machine look like and what it does. So in this video, we are demonstrating. Okay, so this, as I told you, we have developed for brake pad industry in south part of India. So this is how the entire machine look like. So it has a control system, it has an inspection system, it has part loading, and then part rejection system. The operator just loading the part here. You can see he's just kept the part. Then there's the mechanical guides, if you can see my cursor, which are guiding the component to orientation, like you can see, not reached to a particular orientation. Then this is sky blue color, you can see a sensor, which is just giving a trigger that part has arrived at a particular location. So as soon as the part passed below this sensor, now my system know the part has arrived below the camera. So next comes my camera. Here you can see we're using a camera which captures the high resolution image of this component. There comes the part, and it is under dynamic condition, means on a running line we have captured an image. Now on the captured image we are doing some analysis, like we are verifying. Let's say this is components part A type, so that it should have a particular shape. So we're verifying the shape is matching the running line component or not. So it says okay. Second thing, the logo. So this the brake pad manufacturer manufacturing the brake pad for various OEMs like TVS, Maruti, Tata. So they want to show no different brand part should be packed to the different brand OEM. So verifying the particular logos there, then colors like rusting, some things there or not, and the PI presence. So this goes as per the stand, as per the requirement of the running line. So you can see a green box means this part is okay. And as soon as the next part comes, which is not matching with the line, such as shape is okay, logo is not okay, color is not okay. So we can see a red box. So based on that, we're able to judge visually the part is okay or part is not okay. And now the visual inspection is done. This feedback is given to the PLC by the camera system. So we can eliminate the part based on this decision. But here, as per the requirement of the end customer, we also want to verify the dimensions of the part. Now, few of the dimensions are on the back side of the part. So we have developed a mechanism which can flip the part. So as soon as the part come, pause and get flipped. So you can see part got upside down. And now going further. So here we are using a 3D laser profiler. You can see it's a blue color laser profiler, which is designed to capture the data of a dynamic running part as fast as going 500 meter per second or 1 meter per second, depending on the size of the part. So this profiler and a conveyor, we having an encoder feedback. So as soon as the part passed below this sensor, we get the 3D point cloud data. Now on that 3D point cloud data, we have written some logic to measure the width, the height, the flatness, and we have entered the tolerances that this specification. The gap should be of this size, the part length should be of this size, and based on that, the software is showing the part is okay or not okay. And then based on the nominals, this data again going to the PLC, and PLC giving the information to the pneumatic separator. So as soon as the bad part comes, we trigger the separator and it's eliminate the bad part out of the line, and the part which is good goes through and goes to the separate bin. So this way we will to segregate the parts on the dimension and on visual basis. So again, we are just showing you the overall process, how the parts are coming in, how the parts getting flipped, how they are going ahead, getting mechanically aligned, getting measured, and then by using a separator, we are eliminating the part. Now, as I said, as per the requirement, instead of a pneumatic separator, we can use a robo, a pick and place robo, a SCARA robo, depending on what is the production speed. So those things can be modified. So then we're getting all the data on the HMI screen, the dimension which we have inspected, like total length, width, thickness, parallelism, group dimensions, and it is showing okay, means they are meeting the specifications, not okay if they are not. So in this project, you can see we have covered color identification, the profile and number presence, and then dimensionally we have covered total length, profile matching, group width, flatness, black plate thickness, all other dimensions as well as per the customer requirement. So that's how we build a SPIM as per your requirements. So you will, if you can share your components, what exactly you're looking for, what are the dimensions you want to measure, or you want to judge by some visual parameters. So we can create a concept design as I was showing you in this slide. So we can create the concept design accordingly, and then we can have a common discussion. This how the system will look like. These kind of sensors or these kind of cameras will be required to make this work. And we also calculate what tolerances we can achieve, what speed we'll get. So in total, we'll submit a proposal for you. And if that sounds good to you, we can build a SPIM for you, and which can be really, really useful for you. You can reduce your manpower, you can increase your productivity in terms of no human intervention, automatically part getting inspected on basis of visual parameters and also dimensionally, both the things. So again, few pictures of the different process we have covered in this SPIM. Again, everything here is a customizable stuff, and based on your part or your requirement, that thing will be customized. Like for example, if you're selecting a vision camera, we select what megapixel camera is required to do that thing. We are selecting a sensor, then we select what resolution of a sensor is required to meet the tolerances of your part. Everything is customizable. One more example of SPIM, like dowel assembly inspection system. So here we want to show the presence absence. So here we're not doing any dimension measurement, but first thing we are showing the presence absence of a hole. So we have developed a compact SPM, which have a small translation stage. The component is loaded, and then you can see a 2D vision camera on the top. That's how the part look like if you can see the picture. So once the part is loaded, goes below this camera, we take the image, and then we find the holes of presence, absence are there. And based on that, good part goes to a separate area and bad part goes to a separate area. Data is recorded, which we can see on the screen itself, like what are the current values, measurement. If you want to measure, let's say, diameter of the part. So those dimensions we can measure with the camera, and or we can, the part is okay, we say, okay, this part is okay, the feature is present, or the feature is absent, the hole is blocked, like that. So one more SPIM picture, as I was telling with in south part of India, we have made it for ceramic trays inspection. Here you can see we have designed a panel, the sensors from Element Technologies Canada. So this is a 3D laser profiler. It scans the ceramic tray in running condition, and immediately test the part is okay or not okay. So let me try to play this video as well. So this is a real on-site video. So real on-site video of a real machine which we have delivered to end customer. So this is how the machine look like. You can see panels, HMI, which is displaying the results. How many parts are okay in a day shift, how many parts are not okay. And this is the tray which they want to inspect. So here they want to inspect the warpage on the tray. The part is nice and flat, or it is having some warpage. So you can see the operator has loaded the part, because by seeing from the eyes we cannot judge the warpage is there or not, but you can see a laser profiler. As soon as this pass below that laser profiler, we get the data. It has inspected the part and it says okay. So on my screen we can see we got the 3D point cloud data. So we're monitoring the flatness of the part, which says 87 micron. And that's how we can see the path is okay or not okay. Okay, I'm coming back to my slide. I hope my slide is visible now. Okay. So here you can see, yeah, here you can see that this was the actual pic of the ceramic tray, which we were trying to inspect by using this technology. So you can see various groups are there. So in a single go, let's say there are 10 groups in a single go of span of just 2 seconds. We have measured more than 20 dimensions on this part, where their length, width, and depth of all groups are included. Along with that, we have also monitored the warpage in the tray, means the flatness and the curvature. Both things we're monitoring. So just in that single pass span of 2 seconds, we got all these dimensions. So earlier, this customer was using first principle manual method where they use a plunger dial to verify the part is okay, not okay. So hardly they're going to check 200, 300 components in a day. But by using such technologies, they will touch 5,000 components in a day itself by using such machines. One more STM which we have designed. So this is for brake drum brake pad. Like here, we want to segregate the part on the basis on the whole pattern. So you can see there are multiple holes in this curved plate. So here we have multiple cameras which is trying to cover various views on this plate. As soon as this plate comes, camera captures the images and we verify that the pattern is matching the standard pattern of this plate or not. So if it is okay, it is passed to a next station, or if it is not okay, it falls down to a different stage. We'll be showing you the video of this as well. Just a moment, I'll play this video. So this is also a real video machine. This is your download, you can see. So again, HMI displaying things okay, not okay. So that can be customized as per your GUI requirement. Okay, this was the last clip. Okay. So here you can see a 2D vision camera, lights, slider, which will slide the part to, and a printer, which will mark the wet part and good part. Okay. Control system. So intention to show you these videos is just how we customize the entire machine, the sensor, the movement system as per the part requirements. So we're just holding up the process just to show you how the part is loaded. In real time, it's pretty fast. So let's just start and goes to the next station. Now the part is below the camera and it has been captured. So the path was not okay. Very compact SPIN here just to segregate these kind of parts. So it's giving the good part and bad part, and then accordingly they're getting segregated as per the given standard image. So you can see in the end, we can see how many total number of parts were okay, how many of them are not okay. So we have total inspected 13 parts and 7 of them found okay, 6 were not okay as per the required standard. And this was the video which we were just discussing on the slide. So again, this is a real on-site video. You can see one side the operator is loading the part, and on the other side they're getting the okay part here and the not okay part goes down. And the camera here, even using multiple camera to analyze the part from different views. So we are verifying the whole pattern is matching the required standard pattern or not. So that was the okay part. If the part is not okay, it goes down. So all these data images can be stored into a system with the results. And you can, anytime you can go back and see what was the measurement value, how it looked like. So it can be analyzed at any moment. Now what we'll be doing, my colleagues will be showing you the machine live, and we'll be talking about the machine. So just wait for a second. We'll share a screen where we can show you the live demonstration. Where we will be displaying how the machine look like. So we have developed this machine house.
Pavan sir, it is not visible right now. I guess Anil had
Yeah,
joined to your ID only. Let me make him a presenter.
yeah, he's entering. Satyam will be sharing his screen. Just give me a second, and then once the video is visible, then I'll start explaining about the video.
Yeah,
I hope
now it's
now.
visible.
Okay. So here you can see we are displaying a stationary station system where we are using a sensor which is designed to capture area of a part. So here at the bottom, we are having a PCB board. So on this PCB board, yeah, you can see there are multiple components which we want to, let's say I want to verify the height of the part, presence, absence of these components. So once the operator loaded the part, my colleague can give a single click and we got a 3D point cloud data. So that's how the 3D point cloud data look like on the screen you can see. And we're measuring height of the component. So you can see a red color mark which is showing the height of the component is not okay as per the specification is supposed to be. It means something wrong with the connector. It is not mounted parallelly or some misconnections are there. On this, so on this board, you can see I'm able to see all large and small components. I can see both 3D and 2D data, and I can do the analysis accordingly as per my requirements. So visually, if I want to see something is present there or absent there, so I can see that. Other than that, as you can see on my screen, we are measuring dimensions, so we can dimensionally measure the value. So in a single go, now you can see the other connector, which is measuring 13.212. So in that connector, the height is okay as per the given tolerance. So that part is okay. Now, all this digital output can be seen on the HMI screen and can be saved onto your computer or as a report. So if you can see the video feed where we are displaying HMI, and these results are coming on the HMI screen. So total, verifying the total length of the board, which says 117.2. Same way we can verify the width, which is 80 millimeter, 80.8 millimeter. We can verify the hole position for the fitment purpose. Instantly, all these data can be directly sent to a PLC or to a PC for next operation. Let's say if you're using some robot on a line, so I can throw these values to your robot, which can pick the PCB and place it to other line or other station for the next operation. So direct digital outputs protocol is support like Ethernet IP. It can be Modbus. If you're using Siemens PLC, you can even do it on a Profinet. And same time, if you're using any software, so we can give the data onto your PC on a TCP IP, where you can use your own software to analyze, do the further analysis. Now we'll be showing other machine. So this how our custom SPM look like. So here in this image, you can, in this video, you can see we have made a conveyor belt, which is around 2 meter long. We having a 2D vision camera, which is from a brand called Cognex, USA. And there's a 3D laser sensor, which is from LMI Technologies, Canada. So now what we are trying to do, we are trying to judge the part visually and as well as dimensionally. So as soon as the operator load the part, image get captured by the camera, and you can see two tower lights also there. So they are, and one tower light indicating things are okay, not okay from the camera side. Other one shows from the sensor side. Then there's a pneumatic separator which eliminates the bad part out of the line, and you can see HMI screen which will be displaying all the results. So now my colleagues will demonstrate you the real time measurement, like they have passed this part. So this is how the camera has captured the images. And we are trying to find the absence and presence. Anil, do you want to add? Yeah, Anil is open his cam. You can see one more cam where he's just shown you the parts, how the parts look like. And we are trying to see the presence of absence of the rubber component in this part. So good parts having the rubber component along with the metal component, and the bad parts, the rubber component is missing. So that's what a camera is trying to judge on a running line, that the particular rubber seal is present on the metal part or not. Then second thing, dimensionally, we are measuring the diameter and the height of the component on the running line. Until we can test the part just to show how it does work. We need to see the feed from the Anil. Right now we cannot see the video of a machine. Satyam, you can stop sharing the screen and you can switch to the camera, so we can see the live demonstration. Yeah, the video is not visible yet. We can hear you. Yeah, now we can see the video. So now you can run a part just to show. So this is how the part look like. You can see the black color rubber is present on the metal part. And the diameter and the height is a measurement we want to assure in this part. So the second one is the black ring.
there is around 30 mm, that is the NG part. That one is the OK part, and that one is the NG part, based on the diameter. And third one is the another NG part that having the same diameter, but the black ring is missing. There are two cases. First one is the OK part, that is visually okay. Second one is dimensionally okay, but visually not okay. And the third one is
you lost your video. You lost your video.
Pawan sir, we can do one thing, right? Like he can show us the machine and the part, and you can just explain the process, okay?
I'll be doing it then, no problem.
Yeah.
Okay. So you can see the part, how fast the part goes below the camera, below the sensor, and the ejector has eliminated that part. So as soon as you can see the part is passed below the camera, it indicating that it is visually okay, and then below the sensor it shows dimension not okay. So it got eliminated. Green from the sensor goes straight to the bin, which is okay. It is eliminated, preventing like visually or dimensionally not okay, it will be get eliminated. So red means that is not okay. It is get ejected from the part. So the entire system is integrated, talking to each other, communicating to each other, and this how fast we are able to inspect, be able to measure, and be able to analyze the part visually. All the process is happening simultaneously. Like here, you can see the image captured and shows green means the part is present. The part rubber steel, which we want to be in a part, it is present. So this part is okay for me visually. The next part come okay, but this is not okay dimensionally. The diameter ID of the part is not okay. And then, yeah, in this part again, you can see it is not okay in both the ways. Visually, the seal is also absent, and diametrically, it is also not okay. The next part, it is okay dimensionally as well, and the rubber seal is also present. And from the sensor, we will be seeing the height of the component. So camera is telling us X and Y, and sensor is telling us Z axis. Even with the sensor, we're getting the diameter measured. So we will be judging the part based on their ID, OD, and the total height. Now we are switching to sensor. So this is how the data look like in a 3D sensor. So you can see a 3D point cloud data coming out of the sensor. And we are getting ID of the part, and at the same time we're getting a height of the component, and this all data then going as a next step to the pneumatic separator. So if part qualifies dimensionally and visually, then only it goes straight to the okay bin. If it is not okay either dimensionally or visually, we eliminate the part of the line. In the end, on the screen, we can see the total analysis, how many total parts were checked, how many of them are not okay visually, how many of them are not okay dimensionally, in total how many parts got rejected, what are the values of the dimension which we have measured like ID, OD, heights, all those values we can see right away on that screen. And these all data is recorded. Later, we can export all this data into Excel format, when we can have analysis of an entire shift, of an entire day, of an entire week or month. So those data analysis can be done on the later. So we can do the process monitoring, how stable our process is running, how many parts getting rejected daily in a shift basis. We can analyze like shift A, shift B, shift C, which of the shift is producing more bad parts, good parts. So we can work on that area and can improve our productivity. Here again on the camera window, you can see my colleague is displaying with a laser sensor. So it's a blue line laser sensor, highly accurate, 3 micron accuracy in Z axis to measure step heights, and a camera to capture the images, system to eliminate the bad part, And this again, as I said, is a custom thing, so we can design as per your requirement. Means suppose you say, no, I don't want a pneumatic separator over there. I want a robot which will pick the part. So it can be done that way. Even for the part loading, if you say I want a ball feeder which will feed the part, so we can provide a ball feeder which will put the part, or a robot which can place the part on a conveyor, or a manual way. It is right now happening. My colleague is doing the part. So that's completely the choice of a customer, depending on the cycle time requirement, depending on the tolerance available in the part, depending on the production line of how much parts you're producing per day. So we can customize the technology accordingly. So that was our intention today, to show you what Geoinformatics does in the field of SPM. So we specifically work for SPIM. We're not making machines for process automation, but we make machines for automated inspection. So that's why we call it SPM, special purpose inspection machines. So this was just a concept machine we have built in house. Any one of you wants to test your part, wants to see the live demonstration, you are most welcome to our office, which is very near to Kushambi metro station near Anand Vihar. So you can come and view this live in front of you. You can come with your sample parts. We can test your part. We can show you how the things will look like, and then we can design the concept machine for you. And based on your inputs, if things look good to you, we can design or develop a machine for you, which can solve your purpose. So that was the technical stuff which we want to discuss and label. Akash, I guess we should be open for questions.
Yeah.
Anyone having any questions?
Yeah, thank you, Pawan sir. We will go ahead and take some time for questions now. Just a reminder, please be sure to type your question into the Q&A box in your screen left side menu. So as of now, we have some few questions. Like I have two questions from one person, Mr. Arul. He is asking like what expertise is used while using this SPM machine. I mean the operator qualification and all other things. Secondly, he is asking process feeding of dimensions, manual or direct via design software.
Okay, so I'll try to answer these questions one by one. Let me go to the very first question on the chat box, which is please, okay, you have, okay, what expertise are required? So we don't require a very high expertise if you're trying to go on operator level. Once the machine is ready, means program, then operator will be just loading, unloading, and saving the data. So even guys who are on shop floor doing basic stuff can use this machine. Then second thing, during the after the delivery, we plan a training for your, let's say, engineer level guys who can do programming, who can set up a job file. So this programming is not a coding type of a programming. It's a graphical user interface where we take, let's say, from 3 days to 5 days to train someone from your team who can make your own program and can inspect the part, who can feed nominal tolerances of the drawing, and can save those job files, and later they can be run on the machine. Then the second question was process feeding of dimensions, manual direct. So process feeding, in starting, we manually feed the dimensions, like what are the nominal, what are the tolerances. Like if we talking about a design software, then we because we need to train the sensor and the camera what are the dimensions. So in starting, yes, it required a development time to train the sensor or the camera for the good and the bad parts, but it's not a very long process. Let's say you have 10 different types of 20 different type of 50 different type of components. So once you train them, it get inspected. But suppose you make a one program to measure ID. Now your second part comes, which is a different nominal for that ID. But you don't have to create a new program for a different nominal ID, because the system knows the logic. So until that is within the field of view, it will inspect the, let's say, the ID or the total length or total width. So the same program can run for different part, length, width, or diameter. So that's how you can save times in terms of programming. Like next question I got is, do you have SPM for inspection bearing in railway coaches? We have not made a SPM which is doing a rail coach wedding so far, but yes, we can develop such as SPM. If I talk about rail coaches and wagon bees, so we are working on a project already where we are monitoring the track, railway track for the defects and measurement. But if you can share your requirements with us, we can look into those requirements and we can create SPM accordingly. So doable. As of now, we have done the made a custom machine which can inspect the track. So that system is mounted on a running bogie, and it will move over the track and monitor the defects in the track. So that bogie can move as fast as 80 kilometer per hour. And under the dynamic condition is measuring the defects on the railway track. The next question
Okay,
we have.
okay. So, sir, I'll just stop you for a minute. So, I just wanted to say that in the end of this session, I'll be just putting the email ID and the contact number. So, don't worry like how to contact us, like for your requirements, for your personalized demos. We will definitely look into it. But like for now, we will be just focusing on the main questions. So, yeah, Pawan sir, you can continue with the question sections. Okay.
Okay, so someone's written they can be used in dairy plant. So it can be used for verifying the packaging stuff in dairy plant, like after packaging, all things are packed well, the number of boxes or number of bottles are okay, there's no cap is missing, the packet is not damaged, so on a running line. Then you can verify the OCR, the barcodes on your package are okay, and you can read those barcodes and you can keep a track of your products. You can read the correctors, the numbers, the let's say the level of what expiry date, the code number. So all these areas which we can do for packaging and dairy plant. Any other question if you're having, you can leave the question in the chat box and I'll try to answer one by one. What is the accuracy of a laser sensor in a camera? So the laser sensor here we're using are as accurate as 2 microns in z-axis and as accurate as 20 microns in y-axis on a running line. Then the final accuracy of the system will be depending on kind of robo, conveyor, or the mechanism you're using. So if you say you have a very tight tolerance part, it can be inspected, but the mechanism need to be designed accordingly. Then is it possible to check online diameter in a grinding machine? OD tolerance is 2 microns. 2 micron will be a very tight tolerance for a conveyor based application. So those kind of application we surely required a different type of mechanism to handle. But yes, 2 microns possible. For that we use a very different kind of sensor, but it will not be a conveyor based application. It will be a translation stage application with not a laser sensor, but a different kind of sensor which can be used. So yes, you can inspect part very, very accurately, but at the same time, you need to take care of the mechanical stuff and the speed of a production line. Do you have a machine to measure gear profiles? Yes, we do have machine for gear profiles measurement, but if I talk about typical gear testing, yes, then it will be offline machine where it tests complete gear parameters like diameter of pin, span over teeth, lead profile error. But if you just want to verify the profile of the gear, then we can develop a inline SPM which can do it really, really fast way. SPM inspecting 16M thread bolt. Yes, that is possible. We can develop a SPM which can inspect your 16 thread bolts, no problem. That can be designed. You can leave, as my colleague told, Akash will be leaving a contact details in the end where you can send up your inquiry. We will revert back what with resolution for it. I need detailed discussion about a product, so need one person discussion to contact. So end of this presentation, Akash will be dropping an email ID where you can contact us. You can leave your inquiry and my relevant salesperson or technical person will be contacting you. Can you share the presentation PPT? Yeah, we can. You can leave an email, then we can share the relevant presentation and videos to you. How to measure 3-dimensional cylinder threads in a shaft. Okay, yes, that requires a special requirement, because if it is cylindrical part, I need to cover 360 degree. So I need to have a rotating mechanism to cover the entire 360-degree area, and the thread should be in the visible area. If it is inner thread, then I need to choose to offline machine. But if it is an outer surface, yes, we can do it. The next question says by Mr. Arul is, I want to develop an inspection visual dimension system for handling needles. Okay. Yeah, sir. This will be tight application, but yes, recently we have developed this as well. So surely you can leave an inquiry where we have special machine to which specially work for needles. The quality of a needle, the hook, we will assure that there's no defect in hook. Can we, what is the accuracy of measuring 4 inches by 4 inches with 50 micron thickness? Okay, yes, in that case, we're using sensors, which are point sensor, which can monitoring the thickness of a moving part. So resolution of these point sensors are less than 1 micron. Surely it can monitor the thickness of 50 micron running water, no problem. Some of the parameters not visual, they are based on touch. Okay, right now we are using touch-based systems like probing, but I need to have more details to specifically answer that question, which are not visual. Like if you trying to measure the thing which are not visible, surely we can try to do with the contact method, but we need more information like the drawing of a component to show how it can be done. Uh, uh, yeah, we got your ID, sir. We'll be surely sharing the details on this ID. Akash, I think you can also leave your our contact
Yeah,
so people can
yeah,
contact
yeah,
us.
yeah, definitely. I'll be leaving the contacts. And meanwhile, if anyone have any question left, so we can attend it. So please put up your question in Q&A section box. And like like we want to, attend all the questions put by you. So please share with us. So meanwhile, I'll put the ID also in the chat box. So you can, just drop a mail for inquiry or a demo, whatever suits you. So yeah.
Yeah. Even at a later stage, we can, once we receive the inquiry, we can answer your questions in an email. And even like if your application is suitable, we can have one-to-one discussion where my relevant sales teammate from West India, from South part of India or North part of India will be contacting you to discuss about your application, and then we can do some trials for you. We can show you the trials, how the things are working, and things goes good to you, you can proceed further. So my colleague has left us email ID. You can note akashpant@gscpl.com. So on this mail ID, you can share your inquiries, and here's a number. You can dial this number, you can tell about your application, then we can assign some of the engineers who will be specifically talking to you, understanding your requirement, and accordingly we'll try to build a solution which can meet your specifications or requirement. I will be happy to answer any question you
Okay.
having. Yeah.
Okay. I think Pawan sir, we are done. Like we are done with all the questions. So I guess we don't have any more questions. So it's
Mhm.
already 4 o'clock. So I think we should wind up the session also. So
Sure.
yeah, thank you so much, Pawan sir, for this wonderful presentation, and thank you everyone for joining this session also. And like we always come up every month with another webinar for like today we presented you SPM, our Smart department, and what all we can do. But like on another month we will come with another demo, another presentation, another webinar. So stay tuned with us. So yeah, see you. Okay, thank you everyone.
Okay, take care. Bye bye.
Bye. Thank you.